Hello, one dear authors and invited guests. Welcome to Technical Session 6C. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th February 2024, and the virtual event is being held through Zoom, that is 21st and 26th February 2024. I hope you will enjoy the knowledgeable and interactive session through the day. In the session, we have 6 presentations. Each presenter will be given 12 minutes for their presentation and 2 minutes for question answer round. On 10 minutes, I will raise a gentle reminder. If you have any query or update, then you can contact me or write it to me in the chat box. There is another request to all the participants that you all stay connected with us till the closing remark. Just before getting started, I would like to introduce you all with today's session chair, Dr. Katrina, Associate Professor, University of Technology, Sydney. Katrina is a computer scientist and engineer with a strong passion for exploring deep learning technologies and their social impacts. She is the lead research scientist at Project Thrive at the Human Technology Institute, HTI, where she will bring her expertise to work on cutting edge research initiative, modeling, casually making machine learning, and explainable AI. Ma'am, kindly address our participants.
Excuse me, Kartik, I think we cannot hear you.
Hello.
Yes, you are audible. I could hear you the first time.
I think so there must be some network issue. Let's move forward to the first presentation. For the first presentation, I would like to call Celia Fernandez for the paper title Antenna Lab of Soft Wizard IoT Laboratory for Research and Knowledge Transfer. Ma'am, you can proceed with your presentation.
Hello, can you hear me?
Yes, ma'am, your audio is
Okay.
audible to us.
Good morning from Spain. My name is Celia and I'm part of the Fidesol team that has participated in the creation of Atenea Lab. First of all, I would like to talk about the relevance and motivation of the solution we are presenting. Then would like to comment a little on the state of art of current solution and developments. Next, I will talk about our proposal and about a practical example of use. And finally, I will resume the conclusion and the next step for Atenea. In industry, more and more companies want to make use of IoT technology to improve or optimize their processes. For example, in crop farming. But sometimes the investment in the design and deployment of an IoT system cannot be identified at first as a potential benefit in a medium-long time. This revolution has been accelerated for the situation derivative from the COVID. On the other hand, we find that security systems do not advance at the same pace as the development of the new application or artificial intelligence, and there is a very important issue. Égida is a kind of project where we have had different sub-projects and prototypes that we need to build. These projects and prototypes could be deployed in different sectors, for example, industry or food. Also, Égida is a national excellence network whose goal is to do a step up in relation to security and privacy. A wide range of security problems and challenges are covered in Égida, and some of them are IoT related. This encourages us to think about an IoT laboratory to be able to simulate our use case and try our solution. Having such a lab allows the knowledge we can gain from our research to be shared with different companies in more agile way. We propose to create an IoT laboratory that allows us to develop different IoT environments. The main goal is to be able to simulate different device and communication protocols to reproduce and realize scenarios in a controlled way. Thanks to this laboratory, we will be able to design and test IoT solutions for our clients, reducing the developing costs, design and test the cybersecurity solution for IoT scenarios in a controlled and isolated way, and promote the knowledge transfer from basic to applied research and then to real world and companies, and generate a realistic data set for researching, for example, in machine learning and artificial intelligence. All of these permit us to be a bridge between basic research and prototypes to provide an abstraction on the device. For example, only takes the relevant features such as power consumption, battery life, or behavior. A lab is like a Lego where we can build whatever we need under the knowledge that is realistic. In addition, with this approach, we will have flexibility and versatility to build our IoT scenarios and to be able to implement our solution. We can simulate use case and we will be able to launch our experiment and evaluate their performance. But what's the current state of the art? The use of IoT device has grown during the last year. At the moment, companies want to use these technologies to increase their profits and optimize their processes. Prior to carry out the development of IoT ecosystem, it will be advisable for companies to test the proposed design. To do that, there are different options. One of these options is hiring external companies, which usually limited by the IO-Link standard. Another alternative is testing the sensor in a controlled physical environment under simulated conditions. We can find some example of this in IoT Lab 2. However, this type of solution is usually expensive and complex process. For this reason, there has been other proposal that aim to simulate real conditions using software rather than physical environments. Among these options are Omnet++ and Florasat. Both solutions are restricted to specific communication protocols, and the scenario allows reduced amount of devices. Finally, Violet is an environment to IoT emulation at a large scale that is built using virtual machine. But all these solutions have at least one of the following limitations: lack of a graphical user interface, or high cost, or the limited possibilities for the researching. In order to provide a solution for this limitation, we created Ateneo Lab. We propose an incremental design and development of the lab. To do that, we started with a simplified use case. In an IoT environment, we have a device which are connected by a communication protocols that allow them sending their values to a processing center. In addition, each IoT device should have at least one sensor, which detect and measure the value of interest. This functional prototype has a following features. We have a physical layers that allow adding devices which are composed of one sensor or more and have a behavior simulation for a function assigned. Communication layer has the MQTT protocol implemented. which is one of the most extended communication protocols in IoT environments. And management and storage layers has a MongoDB instance running for the persistent storage of the received data. And finally, the application and analytics layer implements an intuitive user-centered guide that allows building and editing IoT scenarios for these results. Atenea Lab was thought and designed keeping in mind on one single goal, be used like a Lego. We have different pieces that, when joined together, create a personalized space. In an interactive dashboard, the user can configure a custom IoT scenario in a simple and easy way. First of all, to create a scenario, we need to include a name, description, communication protocol, and database. Once the environment is created, a set of devices and sensors can be easily created by an interactive wizard. During the process, the user is asked to provide a name and description of each device and sensor. And the sensor needs to complete additional information, including, for example, the type of measurement, units, or the type of generation function. In this release, Atenea Lab have the function like constant, linear function, random values, and trigonometrical basic values. After all the device and sensor are properly configured, the environment can be started. The system deploys a set of containers in the infrastructure and starts the data generation. After defining the time in the environment, the execution is stopped. The Atenea Lab has been tested under different stress conditions to verify its correctness and performance. We detected data loss when a high frequency of sending data is defined in a medium number of devices and a high number of sensors per device is defined. It's possible that some data are lost. This is due to the broker cannot manage such amount of data at a high pace. Also, we detect a band reduction when there is a high number of sensor and device defined and the frequency of sending data is also high. The reception of the message by the subscriber can be delayed, but in any case, the received message are stored shorted in the database. In Andalusia, one of the most important areas within primary sector is agriculture. In the context of Ejida project and in collaboration with the University of Granada, we have developed a prototype for anomaly detection in network traffic for the agri-food sector. The goals of the prototype were testing the Atenea Lab in a realistic use case in the context of agri-food and applying for the first time MSNM sensor in IoT-based scenario. We build a simple use case in Atenea Lab with two devices, one of the environment and another for the soil. For this prototype, we configured the environment with MQTT as a communication protocol and
Sorry to
MongoDB
interrupt,
for the...
ma'am, but you have 2 minutes to conclude.
Okay. And a MongoDB for the database. Each device had a temperature and humidity sensor, and we had one MQTT publisher for each device that sent generated data into the database. We run the scenario to verify all is work properly, and then deploy, for instance, for the MSNM tool sensor. Then we started the simulation of the complete scenario, collecting data under normally operation condition. Finally, we launched some controlled attacks to try the capability of anomaly detection of the tool in this context. The attacks we are properly detected. For the conclusion, Atenea Lab has been designed and built with the purpose to reducing the gap between academia and enterprises, helping to knowledge transfer and digital transformation. This first release of Atenea Lab is a functional prototype that allows building a complete scenario with sensor, device, communication protocol, and database, simulate a complete scenario with different options, and interact with Atenea Lab in a graphical and intuitive manner. As a future work, we plan to evolve Atenea Lab at less of the following points: allow resisting different users, make the laboratory accessible externally from Fidesol, define and try more compare use case, perform an additional stress testing to define better limitation, and finally evaluate the usability and user experience with different users. And that is all. Thank you for your attention.
Thank you, ma'am. Ma'am, any questions?
Thank you very much, Celia. Very interesting talk. I have two questions. So, when you say that you are generating realistic data, how are you dealing with data quality problems? Because sensors, again, they collect very noisy data. How do you deal with the noisiness of the data? And second, what do you mean by attacks? If you could elaborate more on what kind of attacks that you tested your approach.
Well, in the future, we want to extend the different attacks to analyze better the situation. And with the generate of data, we need to do some use case to create some use case to create a data set for the different IoT sensor.
Okay. Thank you very much.
Thank you.
Those were my questions.
Thank you, ma'am.
Yes, okay. Hello?
Yes.
Hello. Yes, I am having one more question. Can you just tell me what is the weakness of your idea, or what can be the future scope of your idea?
Um, the different feature that I can extract is like battery life or humidity values or temperature values. The sensor are many options. Then you can configure it when you want.
Okay. Okay.
So now I would like to introduce you all with our second section chair, Dr. Meenakshi. Dr. Meenakshi, she did her PhD in computer science from SDVU Jaipur, Rajasthan. She completed her research on fault tolerance in grid computing. She has 17 plus years of teaching experience in different academic institutes. Presently, she is in Dr. Meenakshi Professor, Department of Computer Science Engineering, Galgotia University, India, and her research and teaching interest includes machine learning, grid computing, theory of computation, complement design, operating systems, intelligence system, data structures, etc. Ma'am, kindly address our participants.
Yes, thank you so much for just give a brief introduction about me. Thank you so much. Due to some network issue, I was not able to connect earlier, but now just 10 minutes back, I have connected the session. Yes, in the mid of the previous presentation, I was connected, so I was not able to listen the complete presentation by the participant. But it's okay. I would like to just welcome rest of the participants who are going to present their papers in front of both of the sessions. So welcome everyone who are going to present their paper. Thank you so much.
Thank you, ma'am. So we are moving towards the next participant. For the next presentation, I would like to call Blinskaya Yulia for the paper title Covering Based Feedback Verification in Gazebo Simulation for Husky Mobile Robot. Ma'am, you can proceed with the presentation.
Good afternoon, colleagues, and I will restart my presentation. Okay, do you see the presentation?
Yes, ma'am. It is visible to us.
Okay, so my name is Belinskaya Yulia, and I want to represent my work which is dedicated to covering-based feedback verification for gazebo simulation for Husky mobile robot. In this work, we want to propose a new approach of covering method to build and feedback. But first, I need to quickly introduce you the covering method itself. The covering method is considered for the control dynamical system 1, where X is a state vector and U is an input or control of the system. And we also suggest that the function F is smooth, so infinitely differentiable. We also consider the two-point boundary control problem 2 for that system, where T0 is the initial time moment and TF is the final time moment. The covering method itself considers that we found the function U and phi of variables of the system, including some derivatives of the input, including not only the input itself, but also some derivatives up to some finite order. And those functions must satisfy the conditions A, B, and C. So the conditions A requires that there is a covering from the extended system into the system of function P. The condition B required that from the finite, from the final state of variable X, we can definitely find the final state of variable P. And once we have the function P, then we can find the derivatives of the control. So if those conditions are met, then we can solve two-boundary control problem with these 4 steps. So we calculate the final conditions on the function P. Then we solve the Cauchy problem for function P in reverse time, so from the TF to T0. Then we find the initial conditions for function U, and that means that the system 3, 4 have the full number of initial conditions. So we can just solve this problem as Cauchy problem. So this scheme is represented the covering method on the graph. So we have the problem, which is the system with control and initial and final conditions. We build a so-called error closure. So it's extending of the system of initial system. Then we build covering. So we find the functional P, and the functional P can define covering from the extended system to a simple system on function P. Then from the final conditions, we find the final conditions on function P. We solve the Cauchy problem and find the function P. And then we define the whole initial state for U. Here U tilde represents for U and the whole number of derivatives of U, and that's help us to find the final conditions. So how can we use this method for build a feedback? For build a closed loop design. We suggest that the system is flat. We suggest that we build the solution of two boundary control problems, and the most requiring condition is condition number 3 here, that control parameters can be found not only in initial time, but also in every moment of time. That's quite a strict condition, but it can be met while the system is flat. And we also suggest that the covering defined in equations 10 is solvable in terms of variable 9, as I said before, in every point of time. So then we have the Cauchy problem solution, and these control equations that solved the point not only in initial time but also in every moment of time. We consider that the equation as a closed loop control for two boundary control problems, so it's feedback. But that control can be unstable, especially at the finding when the time is 10 to final time. And that's why sometimes we need to add so-called stabilizing term, 1113. It's the term that must such that the arrows of the state must tend to 0. So it must be differential equations with stable points. Okay, let's discuss our method for a Husky mobile robot, and then I will represent the gazebo simulation for that mobile robot. The kinematic of this robot is quite simple, is equation 14, and we have also the boundary control problems 15, and that system is flat. We can prove it with the simple calculations. I proved that here. The most important thing that we need to notice that x and y is control variables. Well, it's not control variables, it's the flat output. And can be, and all the control variables can be represented in terms of derivatives of that output. The additional variable is c, and so we have the additional system 19 of 4 variables, not only initial x, y, phi, but also additional variable c. So, and that augmented system is equivalent to normal Bernoulli form of equation 20 with the new control variables eta. But we also must to notice that the system is flat only when the speed v is not equal to 0. So we must also add the boundary conditions for additional variable. And we also suggest that restrictions on control variables are applied. So velocity and angular velocity control variables must be limited. Okay, if we have proved that the system is flat, we have the boundary conditions in terms of flat output, which can be computed with these equations. And the reference trajectory are found as a polynomial of function t and the initial and final conditions. So that's the reference trajectory which represented the movement, which is satisfied the following conditions. We also suggest that we found the conditions for additional variables. So if we compute new control variables eta, it represents with the equations 25, and open loop control can be computed with the equation 26, where eta is founded here. So the stabilizing form can be looked like that if lambda din and lambda 2 is some negative numbers, practically arbitrary. So, and the equation 29 represents the closed loop control in additional variables. As you can see here, that feedback based on the flatness of the original kinematic model, and also depends on the arbitrary moment of time t. So we have four control approaches to check. The first one is quite simple. It's open loop control, which is represented with the equation 23. The second is based on the first approach, but with the stabilizing form here on the slide. The third approach is the approach that we represent. So it has computed the variable eta, which is additional control, and
Sorry to interrupt, ma'am, but you have 2 minutes to conclude.
oh, I'm sorry. Thank you. So, and third method is represented in equation 30. And fourth method is basically just the third method with the stabilizing form. Okay, we define some boundary conditional and control constraints, which is represented here on this slide. And then I want to show you trajectories that we found. Here I comparing first and third approaches. So first approach is open loop control, and third approach is our control. And we can see the first approach works very bad. That's the reference trajectory, and that's the trajectory of our robot. But our approach works well, even if he has some difficulties in the beginning. The open loop control works bad because of these two reasons that I found in the slide. This shows the graph for angular velocity and explains why the controls just work so bad. We don't have the initial angular velocity for the open loop control, and that's why our robot cannot turn to the right angle. Here they're comparing second and fourth approach. Both approaches works well, but our works a bit better. As you can see from this graph, there is mistakes, detailed comparison. It's an error of the control and an error and x and y states. So here you can see the graph for angular velocity control, and as we can see here, for our approach, control requires less movement. So it will be also helpful if we have limited amount of control, if we have limited amount of times when we can switch the control on and off. So that's the end of my presentation. And questions?
Thank you, ma'am. Ma'am, any questions?
Thank you very much, Yulia. So I come more on from the machine learning, deep learning side of the world. I have maybe some esoteric questions. So I know that are you aware of reinforcement learning approaches in the machine learning? Have you heard that term before?
Well, we tried for our robot, but we still need to represent. We want to implement our approach in reinforcement learning.
Aha. Okay. So you mean that all these these models that you developed, they can be transferred to like a policy learning mechanism in reinforcement learning?
Yeah, it can be used like a policy, and that simulation results require can show us that it will be one of the useful policies.
Okay. And the second question is how scalable this approach is for more dimensions. So here you're in 2 dimensions. So how scalable would this be, or it's a very difficult, completely out of scope?
Well, actually, it's not very difficult since the system is flat. Flat doesn't mean that it's planar. It has only two variables. It means that it can be. It means of the terms of flatness. So it can be represented in some functions which we call flat output. So even then, the system have several dimensions. It can be represented as flat systems, and that's why our approach can be quite easily, I would say, applied for more dimensional systems.
Awesome. This is very interesting. Thank you. Thank you very much for your talk. Thank you.
Thank you very much for the questions.
Thank you.
Yes, thank you, Julia. Okay. Yes, I am having one more question. Can you just tell me how many coordinates you have used for your data? Whatever data set you have used for that, how many coordinates just you have considered?
Excuse me, how many?
How many parameters you have used in your data set? Like we are using deep learning for the multi-dimensional data set. So how many parameters you have considered for that?
We had represented model in gazebo stabilization, and we considered only parameters that describes the system itself.
Okay, and which algorithm you have used for that?
We used
Can you just tell me the name of the algorithm?
The name of the environment?
Yeah, algorithm.
Gazebo. That's the simulation environment, which can be used to.
Okay.
Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I like to call Yasmina Alami for the paper title, Exploring the Extendeds of Purchase, Intention for Organic and Healthy Foods, a Systematic Literature Review. Ma'am, you can proceed with your presentation.
Okay.
Yes, ma'am. Now you can share your screen.
Can you allow me to share the screen? Okay. Do you see my screen?
Yes, ma'am. Your screen is visible to us.
Okay, 1 moment, please. I just see my screen.
Yes, ma'am. But yes, ma'am. Now it is clearly visible.
So, hello. I am here today to talk about our work that we made in University Hassan I in Morocco about exploring the antecedent of purchase intention for organic and healthy foods through a systematic literature review. So nowadays, consumers are increasingly concerned about their health. They are demanding and seeking information before purchasing a specific food product. And this trend is encouraging them to learn more about organic products and seek out healthier foods. So these changes impacts consumer purchase intention, which consequently influences their final behavior. So our study represents a systematic literature review of current research between 2010 and 2023 related to antecedents and attributes influencing purchase intention for organic products and healthy food. The aim of the study is firstly to synthesize the different antecedents and attributes that influence the purchase intention of organic and healthy food products, and secondly, to propose to our study a conceptual model based on the theory of plant behavior by adding other antecedents identified by existing research in the literature. So for the methodology, we followed the methodology proposed by Denier and Trentfeld, which is structured around 5 steps. So the first step was the preparation of the research question. So for our systematic literature review, our research question is which attitude and the antecedents influence purchase intention for organic and healthy food products? The second step is the search for studies related to this research question. So in our case, we use the Google Scholar search engine. We explored several databases during our search, including Springer, Science Direct, Elsevier, and for which we used the keywords such as purchase intention, determinants of purchase intention and organic food, purchase intention, and healthy food. So once downloaded, all articles were imported into the Zotero software with the elimination of duplicate article. And then the third step was the selection and evaluation of the studies. So we applied a specific set of inclusion and exclusion criteria. For example, for the exclusion criteria, we took into consideration it was that articles should be published before 2010. The articles should be written in the articles not written in English and French, and the articles dealing with other aspects of purchase intention other than antecedents and attributes. The inclusion criteria were articles discussion conceptual models of antecedents and attributes of purchase intention, articles written in French and English, and article published between 2010 and 2023. So by eliminating, by using this criteria of exclusion and inclusion, and by eliminating the duplicate articles, we retained 33 articles for the analysis. So for the analysis, as you can see, it's a table where we sum up all the antecedents that were mentioned more than twice in the articles of the that we maintain for the analyze. So as you can see, the most frequent variable are attitude, subjective norms, and perceived behavioral control. Those are the top three, and those are the determinants of the intention according to the theory of planned behavior, which is a significant social cognitive model that explains variation of in evaluation behavior, and it's an extension of the theory of reasoned action. And for the rest of the attributes, we tried to group them in 4 groups. For example, we grouped the environmental concern, perceived environmental responsibility, environmental knowledge, on the environmental concern. The same, for example, perceived price and perceived consciousness. For example, you can see that all the items related to health, we grouped them into health consciousness, which leads us to develop and propose our proposed conceptual model of the antecedents and attributes that influence purchase intention for potential future research on the topic. As you can see, there are the 3 determinants of intention as per the theory of planned behavior, which are attitude, subjective norm, and perceived behavioral control. And we added the 4 new antecedents, which are health consciousness, product quality, price consciousness, environmental concern, and health consciousness. Through our systematic literature review, we listed those attributes, and we proposed this model, but we found some limitation. The first limitation is that this is the specific context of the study. We have identified the attributes and factors that influence purchase intention without specifying whether we can generalize them also for online purchase intention. And we can question whether those results can be generalized to other organic products, such as cosmetics, personal care products, and cleaning products. The other limitation is about the country of the study. The attributes and factors can influence purchase intention that influence purchase intention may change from one country to another. So that's it for me. Thank you for listening, and I'm happy if you have any feedback that can help me through the next step.
Thank you very much, Yasmina. I have a few questions. Actually, it was good that you pointed out those limitations because that's where actually are the interesting outputs of this work. So I hope that you will continue the research that you started here to that since you have the data to try to analyze those limitations that you pointed out because they're really relevant questions. One question that I have, I think it's a little bit related with some of the limitations that you pointed, because you started your literature review in 2010 and you scoped it until 2023. In the meanwhile, during that time period, you captured a lot of volatilities in the economical world. In other words, there was a financial crisis that was hitting very badly European countries. And of course, that changes consumers' behavioral patterns. And again, there are also other types of phenomena that may be influencing. So you did not make any analysis by time frame in your study, did you? You just collected as a whole.
Yes, actually, it was the purpose was only to look for the antecedents of the intention without taking into consideration other parameters such as the financial crisis, for example. But as I said, and as you could understand from the limitation, there is a lot of work to do after this overview. And I hope that this work will help us and other researchers to find out through, for example, empirical studies, what's really in the field.
Yes, I agree. Actually, trying to validate if those factors still are effectively validated. Like you say, different cultures look at the products differently. They have different behavioral patterns in terms of purchasing. So yeah, just I guess the comment that I have is it's a great starting work, but I'm looking forward to see you here next year with the new groundbreaking innovations that you found.
So much for your encouragement.
Thank you.
Thank you.
Thank you, ma'am.
Yes.
Yes, ma'am. Any
Hello.
questions?
Yes, Meena. Yeah, yeah.
Yes.
Actually, I'm not having any question, but I just want to give you a suggestion. Like this was just a literature review, and whenever you will just going to start your implementation work, I think I think a dietitian would be involved with your. We can say that the implementation part because I think we are the technical people. We can just do something with the technologies, but I think the basic things which are required for the healthy food, the rest of the things, I think only dietitian can just give us a complete suggestion for that. So I think you should take these kind of suggestions by some dietitians.
Okay. Thank you, madam, for your comments. Thank you. I will take it into consideration. Thank you.
Okay.
Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I would like to call Renhard Kanapke for the paper titled Secure Connections in Local Networks Despite Multiple Stakeholders. Sir, you can proceed with your presentation.
Thank you. Welcome to my presentation about secure connections and local networks despite multiple stakeholders. This is shared work with my colleagues Dilmari, Sören, and Carsten. Before going into the details about our work, I'd like to tell you a little bit about the setting. We are concerned with industrial Internet of Things. So let's assume for the moment that we are designing a factory. Inside such a factory, we have multiple stakeholders. For example, the owner, of course. However, usually when you build a factory, you don't build all of the machines yourself. So you have the manufacturers of the machines also, and hopefully you have customers. Customers order specialized products that get produced in your factory. So One of the major problems that arises here is the question, who owns which data? One of the things manufacturers of machines nowadays do is they collect data about the running of the machine. So how long has it been running? What is the input? What is the output? What is the power consumption, etc.? The reasons for this are manifold. For example, they want to know about the wear and tear on the machines. Maybe there's a maintenance contract, or maybe there's some licensing model which allows the user to use it in a certain way, but not in others. And of course, for this, it's a valid claim of the manufacturers. They want to collect data. However, you usually don't buy all of your machines from one manufacturer. So there's multiple manufacturers of machines connected to your local network. And now the interesting question is, do they really only collect the data about their own machines? There is more data on your local network, and they are not officially allowed to collect this, but don't they? So one way is to say we trust everybody. The other way is to say, well, maybe we should take some measures. This is not only because of the manufacturers, but it's also because maybe the customers want privacy, because how their products are manufactured in our factory might be a company secret. And of course, we as owners also want control over the data. So we need some kind of security measures. When you talk about security measures and internet or industrial Internet of Things in general, there are two approaches that come to mind right away. One is username and password, and the other are certificate-based options. Username and password is good for a human logging onto a machine because you have the username that might even be known to anyone, but the secret password is only known to the human, and the human hopefully does not tell anyone. And when you log on, it is compared with an encrypted version of this password, so it's really a secret. Certificates are on a different way. We build a chain of trust. This means we always need to be able to connect to some authority we trust. This is usually some authority on the internet. And certificates can also, like passwords, get lost. So we need possibilities for revocation of certificates. Usually, the easiest way is that they are issued only for a certain amount of time. This means after a certain amount of time, you will have to reconnect and get new issued certificates. When we combine these two, the industrial Internet of Things and the security measures, we actually are not so happy. Why? Username and password, like I said, works well for a human logging onto a machine. But when we have machine-to-machine communication inside our factory, then we would have to store username and password in plain text, and we would have to transmit it over the local network. This would mean that anyone who has access to the local network, so the machines from a different vendor, now get our username and password if they sniff the network. So this is not the way to go. Certificates offer a better way, but there's a catch, which is this required internet access. But when I am the owner of a factory, I absolutely do not want my factory to be connected to the internet all of the time and all of my IoT devices to be connected to the internet all of the time, because, well, this would open so many attack vectors. I don't want that. So we had to come up with a new way to make certificates work without the internet connection. This is what we call PKI2Go. It is based on certificates, so we also use encryption with public key and private key, and we remove the requirement to be always connected to the internet. I will show you in a moment how it is done. Actually, we require one single connection to the internet, but not permanently, only at the time of the instantiation of the network. So when we're building the factory, then we need one short connection to the internet. After that, we can locally take care of device attestation, runtime authentication. We can even create multiple virtual local networks to isolate our multiple stakeholders. We can do recovery after the loss of a certificate, and we can do some resets without enabling denial of service attacks. Why is this so important? Because when I do recovery after loss of a certificate, I can no longer communicate encrypted. I need to communicate in plain text again. And this would usually open another denial of service attack vector. But we found a way to prohibit this also. So let's take a look at an example network. We have here a small setup for our factory. It's just 7 IoT devices and 1 PC. And in the first step, when setting up our network, we connect the PC to the internet in order to download certificates for the hardware from the hardware manufacturer. After this, we disconnect from the internet. With the certificate from the hardware manufacturer, we can now do device attestation. For this, each of the IoT devices has one private key burned in at production time. So it can never be changed, and we can use this in combination with the certificate from the hardware manufacturer to confirm that all of the devices we are putting into our network are original devices. Now that we have made sure we have only original devices in our network, we can start setting up the applications with a number of our IoT devices. With the first device we create and load a root certificate onto this device. This becomes now the server for one of our applications. This certificate will be signed by the private key of this device and distributed to all of the other devices we want to share in this application. This means that from now on, all of the clients can authenticate the server and no fake server attacks are possible anymore. At the same time, the service users, so the clients of our server, receive user certificates signed by this management device. This also includes a role description, so not everyone does get all of the rights. Maybe some are get only read rights, some maybe get writing rights, etc. And this is also signed. Therefore, this means we can authenticate clients by the server. So no fake clients can access the server anymore after this step. One of the important features of this is that it also enables secure asynchronous communication. As we have heard before, MQTT is used in many IoT applications, and MQTT has an asynchronous communication set up where the sensors, or let's say some clients, send a message to the broker, which then distributes it to all of the clients, some publishers send the message to the broker, and the clients receive it from the broker. And publishers and subscribers do not know each other. Therefore, we need to have this asynchronous secure communication. Another feature that is achieved is, as I said before, we can set up this group of devices to communicate with each other. And there's nothing preventing us from having multiple groups in our local network. This means, as you can see on the figure in our example network, 2 IoT devices want to communicate. They work on application 1, and they form a kind of virtual local network 1, because all of the communication they share is encrypted and nobody except them can decrypt it. So even though they share the same physical network with virtual local network 2 and with 2 other IoT devices and the PC, their communication is secure. The only thing that other devices can infer now is
Sorry
that
to
there
interrupt,
is...
sir, but you have 2 minutes to conclude.
Okay, so the only thing that can be still inferred is that there is communication taking place, but nobody can discern what type of message is communicated if they are not part of the virtual local network. So what have I shown you today? I have shown you PKA2Go, our certificate-based protocol for Internet of Things devices. We made sure that no permanent internet connection is required. A single short connection to retrieve the manufacturer's certificate in the beginning when setting up the network is enough. I've shown you device attestation and runtime authentication. Due to time constraints, I could not show you recovery after certificate loss. For this, I will have to refer you to the paper, but we also covered this. And we introduced secure asynchronous communication for MQTT and similar protocols, as well as virtual network, which isolates different applications, so different stakeholders, different machine manufacturers from each others. So we no longer have the problem of possible data theft. Thank you. This ends my presentation, and I would be delighted to answer any questions.
Thank you, sir. Ma'am, any questions?
Thank you, Reinhard, for your presentation. I have to say that security is not my background. I'm Portuguese. Security and Portuguese people don't combine. But I have a question. Is there like a quantitative evaluation of your protocol? Were you able to test in real situations where you actually show that your protocol is able to defend you with against more attacks than the other approaches that are there?
Well,
Or is
the
just
main
theoretical? Or did you really test this protocol in terms of physical attacks, where you try to quantify how many times your protocol was able to defend against these attacks versus existing protocols, or this is just the theory being proposed and no, you haven't tested it?
Okay, so the thing is, in reality, I do not own a factory. So they cannot really test
theoretically,
real setting. But we have made an analysis of the different attack vectors that we are now able to hold off. The main thing being that for a long time, most of the defenses against cyber attacks were only targeting attacks from the outside. And we are now taking care of attacks from the inside.
Got you. Okay. Understood. So, okay, I understood here in the, okay, thank you. Yeah, that was an important clarification. Yeah, okay, thank you. That's
Thank you for your question.
Yeah, thank you.
Ma'am, any more questions?
Yeah, there is no question from my side.
Okay, ma'am. So we are now moving towards the next presentation. For the next presentation, I would like to call Santa Arizumi for the paper title Sound Source Distance Measurement using Complex Pair Bayesian Estimation with a Small Microphone Array System. Ma'am, you can proceed with your presentation.
Okay, can you hear me?
Yes, sir.
Thank you. So I share my screen. Please a moment. Can you see my slide?
Yes, sir. It is visible.
Okay, thank you. It is a great honor to be able to speak to you today. My name is Senta from Japan. I'd like to talk about the method for sound source distance measurement using a microphone array small enough to be mounted on a smartphone. So I'm going to divide my presentation into 5 parts: introduction, problems and purpose, estimation methods, evaluation and results, and conclusion and outlook. Introduction. And this study is aimed to measure the distance to a sound source using a small-scale microphone array. This can be applied to sound source separation using a microphone array so that the situation like this picture. You are shooting the person talking with a smartphone, only the desired sound. can be recorded while eliminating other noise. So there were several problems in the past related studies. First, of the amplitude and phase that make up sound waves, only amplitude was used in the study. Second, it assumed an externally ideal situation of only one sine wave. Therefore, there are two purposes in this study: increasing the number of sources to be estimated and expansion of sound source signal to speech signals. I will now briefly describe the estimation method used in this study. Firstly, I would like to explain the configuration of microphone and voxels. That's a candidate for sound source location like this. 4 microphones are arranged on horizontal axis, and it forms a small array, 15 centimeters long. And the boxes are placed vertically up to 15 meters away. This configuration was designed to facilitate distance measurement ranging from several meters to about 10 meters using a microphone array integrated into a smartphone. From the microphone and voxel configurations just described, we can formulate our problem. The spectrogram from the microphone is the vector y, and the amplitude of the voxel is the vector x. We can assume that the two are connected by this equation called linear discrete models, and epsilon is a noise. Considering the distance and like this between the microphone and the voxels and the time delay, this tau, the element of the vector y like this. And from this equation, we can make the transfer function h. Invasion estimation, which is used in various fields, it is known that sparse solutions can be obtained by assuming that the variance of the prior distribution p of x is independent for each element of x. Most elements from x1 to xn are very close to 0, and only a few elements are non-zero. This estimation method, called sparse Bayesian estimation, is suitable for our problem, which considers situations where the sound sources are located in only a few locations among many voxels. And this is the flow of estimation, so I will explain about it. Firstly, the sound waves observed at each microphone is segmented by Hanning windows. Next, the first Fourier transform is applied to each sound waves and focus the frequency bits omega, and with outstanding amplitude for making the vector y. For each vector y, estimated vector x using CFA, concave function algorithm, and the transfer function h omega. And finally, the estimated distance is calculated from each vector x and averaged to obtain the final estimated distance L hat is obtained. So I'm going to talk about the evaluation by computer simulation and its results. First, we experimented with the external ideal case, where only one sine wave was placed. This figure shows the results of 100 estimations for each of the sine waves. For one sine wave placed every 25 centimeters from 0 meters to 10 meters. The horizontal axis is the real distance placed, and the vertical axis is the estimated distance. and the circle indicates the mode of 100 estimations. When the frequency of the sine wave was 200 Hz, circles are in the red zone up to the 3-meter position. So distance could be estimated to about 3 meters. For 100 Hz, and the distance could be estimated to about 5 meters. For 200 Hz, the distance could be estimated to more than 6 meters. From these figures, it can be said that the estimated distance limit improves as the frequency f increases. Therefore, we can conclude that this method achieves a higher performance when dealing with sound source signals with higher frequencies, because the phase rotating among the microphone increases. Next, I show the case of two sine waves. You can see an overlay of the estimated amplitude pattern when the position of the sound source 2 meters and 5 meters, and the frequencies of the sine waves are fixed. Their estimated amplitude pattern is the visualization of the vector x resulting from the estimation, meaning that the estimation location of the sound source is at the position where the peak is formed, like this. And when the frequencies were same at 500 Hz, this figure, the pattern formed many peaks near 2 meters. The location of the source in the foreground and no peaks at the distant source. When the frequency were different at 100 Hz and 500 Hz, these figures, the peaks are formed at the correct position on the front side and on the far side. This is because we estimated independently for each frequency being, resulting in independent estimation for each sound source. Since examining its use as sine wave, one sine wave was too ideal, we next concluded an experiment using two voices. A female voice,
Thank you.
thank you, was used as S1, and male voice,
ありがとうございます。
ありがとうございます。It is thank you in Japanese was used as S2. Let the distance of S1 and S2 are L1 and L2. For cases where L1 is 3 meters and L2 is 4 meters, these figures, only S1 is estimatable, like this. However, for L1 is 4 meters and L2 is 3 meters, both sound sources are estimatable. Therefore, we consider that this method can accurately estimate the distance even for more realistic sound, such as speech, especially when a higher frequency sound is located further than a lower frequency sound. We performed the estimation for various combinations of S1 and S2 placed at a distance ranging from 0.5 meters to 5 meters. Error E of L1, L2 for the sound source distance L1 and L2 is defined as the Euclidean distance between the coordinate L1 and L2 consisting of the true and estimated value for each combination. You can see this heat map. It shows the error of each configuration. In this figure, the black areas like this indicated situation in which ranging is possible only or near audio source. These two figures show that it can be observed that when L1 is longer than L2 in here, the error is typically around 0.1 meters, 10 centimeters, indicating that ranging is achievable. This is because within the same time segment, S1 and S2 have different frequency peaks, thereby reducing the ranging problem when estimating two sine waves with different frequencies. However, when L1 is shorter than L2 in here, the errors are larger and the ranging is possible for S1 only. This is because the higher component frequency of the male voice S2 is lower than the female voice S1, resulting in low estimate performance. I would like to conclude with a brief summary and the future outlook. First, we extended to complex estimation using even phase information. Second, we considered realistic situations, and we plan to improve the estimation accuracy using the two-dimensional spectrum as the transfer function. That's all. Thank you for listening.
Thank you, sir. Ma'am, any questions?
Thank you very much, Santa. Just a quick reminder, what exactly are the parameters L1, L2? Can we go back to your slide with the validation?
Okay, I show
where we
my
have
slide
the-
again.
Can you
So-
remind?
Again, sorry.
Yeah.
Okay, I show a slide. Okay, which slide you say?
Yeah, this. What is again
Okay.
L1 and L2? Can you remind us what exactly means? Because I would like to understand why you don't have results on those darker areas. Why were you not able to compute the L2 norm on that? Or the mean square?
So you mean that why
Yes.
the black area exists?
Yes.
So we use the pattern of the vector x to make estimation distance. You're right.
Yes.
And it is so difficult to more than 2 or 3 sound source because it is only just one peak. It shows one sound, but we should make some more technique to decide 2 or 3 source in this peak this pattern. So one only in black areas there is one peaks in this figure, so we cannot find 2 peaks in this black area.
Okay, it's for multimodal distributions. Okay, got you.
Okay, thank you.
Okay. Okay, this is interesting. Have you considered comparing this with the other distance measure, sound distance measure approaches?
Yeah, so we plan to use to improve the accuracy to the two-dimensional spectrum technology. We planned it.
And current algorithms, have you tried other algorithms besides
yeah.
yours?
You mean this slide?
So I imagine that your algorithm is not the only one in the literature that tries to do this, right?
Yeah, so we don't make more another algorithm yet, but it is so nice plan to our research. Thank you.
Okay, thank you very much, Santa. Very
Thank you.
interesting.
Any more questions, ma'am?
Yes, Santa, I just want to ask how many samples you have collected for female as well as male voice?
Sorry, sorry, your voice is little small. Please say more again. Thank you.
Okay. I just want to ask how many samples you have collected for the females and male voice?
So one voice, one female voice and one male voice we used. So we plan to more voice, another voice we planned.
I just want to say that there are different accent. I think if we are just going to consider the different countries' data, everybody is having different accent. So I think you
Yeah,
should be
yeah, you're
having
right.
more
So
samples so that you can easily, you can just easily discriminate the difference between the male and female one.
So yes, so we now I use just the voice, only English and Japanese voice, but also we need to use more language voice, and also we need to use another, not a voice, like a sound from nature, bird tweeting or anything. So we need to more and more voice used. Thank you for your comment.
Yes, just with voices. Yeah, you should add some more samples for that. Okay,
Thank you.
nice presentation.
Thank you.
Thank you, sir. Thank you, ma'am. Now we are moving towards the next presentation, Chakwin Iguchiga, for the paper title, Voting Secure and Transparent E-Voting System. Dear presenter, you can proceed with your presentation.
Good morning for everyone.
Good morning,
Okay,
sir.
let me please share my screen. Mhm. Can you watch my screen? Sorry.
Yes, sir, your screen is visible to us.
Thanks. Good morning for everyone. Today I'm going to present my presentation about my paper, Voting, Secure and Transparent E-Voting System. First of all, we have here the overview with the topics problem, the objective, the related work, design, development, validation, results, and conclusions. First of all, the main problem in Peru is that some educational institutions needs to carry out some electoral processes to support students to choose the authorities who can represent them uh, with a good electoral, with a good e-voting systems. Other problems that we can find in Peru is that there is a no good voting culture. Also, some students are disabled to vote in person. And unfortunately, in Peru, there are some cases that votes can be manipulated. One case could be that in 3 years ago in Peru, there was an election. People disagree with the result due to the the results were not so clear. What's voting? What's our general objective? Voting is an e-voting system that want to guarantee free fraud electoral processes with different authentication methods, such as facial recognition, one-time password authentication, and encryption. Related works. We have collected different information from different journals, websites, and books, such as papers of Mohamed, Gou Chang, Mejias, and other authors. Here we can appreciate the physical architecture that we can find the front end, two applications. The first one is the mobile application that consists in that students could vote through this application. And the other one is the administrative panel that administrator could use it to administrate the elections. In the backend, we can find the services. First of all, the database that we store only in the data of the votes and elections. Also, we can find the service of Amazon recognition that we use to compare pictures of the students with the university students picture that we can find here. It represents the servers of the university that we want to collaborate. And finally, we can see the email service that we use to the OTP service, the one-time password, in case that the facial recognition wasn't working. Here in the logical architecture, we can find the principal functions of the system. That could be the creation of the electoral processes, the electoral card, the face authentication, also the OTP authentication, the audit the vote. Here in this picture, we can appreciate the design of the applications. The right one represents the mobile application that the students use to vote. And the left one consists in the web administrator panel that the administrator use to administrate the elections. In this picture, we can see in the web administrator panel the election dashboard and a list of processes, electoral processes. And here the administrator can begin, finish, and see the result of the elections too. And also can create the elections and the cards. In the encryption module, we are using hybrid encryption. And it's consisted in the use of RSA encryption and DES encryption. And how this hybrid encryption is used. After voting, the information, not sensible information of the student, just the university code is stored with the data of the vote in the database, and it's completely encrypted. In this picture, in the first picture, we can appreciate the face recognition module. We can see that in that case, my partner was taking a picture of his face. And the picture will be compared with another picture of him. We have tried with a mask, with different glasses too, and the recognition service could recognize in this case, my partner. In the OTP module, in the case of the authentication of face recognition was not working, this other authentication method can be used. Code is sent to the institutional email, and only the student needs to put this code into the application, and the student could be authenticated too. And finally, in the last picture, we can appreciate the voting module. There is a list. We can see a list of the different candidates that the student can select. We have validated this application by 31 students, and we have asked 10 questions about it. We have classified these 10 questions in 3 classifications. The first one is the user satisfaction. With these 3 principal questions, we have measured this classification with the Likert scale. And here we can see the legend of the classification. And we got an average among these three questions. And the result was that we got a 4.62 over 5. With the same method, we have measured the classification user confidence in the application that's related more to security. And with those three questions, we got an average on the Likert scale with a score that is 4.61 over 5. And finally, the last classification is the app information compression by the user. This classification is related that in the application, we share some important information about how to vote well. We got a good score that is on Likert scale 4.57 over 5. Conclusion: according with our results, we have an idea that voting is a good voting system that is easy to use. It has a good acceptance, that it's more than 90%, and also with the survey, students have told us that they would recommend the the application with their friends. Thank you very much. Thanks for your
Ma'am, any
attention.
questions?
Thank you very much, Joaquin. Again, security is like my kryptonite, but I think in here, since there's a little bit of AI in the middle, I think I can touch on that side of your proposed approach. First of all, a general comment. I always question myself why in countries, for instance, I can tell you that in Australia, we have to do the voting in person or in postal, go to the do it by postal. So there's never technology involved. First, I would like to understand your general opinion why countries resist the digitalization of e-voting, and then I can ask you something about your AI on the facial recognition.
Please, can you repeat again the question, please?
I just wanted your general view of why so you came here with a nice prototype of what would be an electronic voting system. I would like to understand your opinion why countries nowadays are still resisting in the adoption of electronic voting platforms.
How it's resisting?
Yes, why countries are resisting the integration of such electronic systems in their voting processes? What do you think? It's just an opinion question.
Well, I think about the resisting pardon, sorry, I couldn't get exactly your idea.
So I just would like to know your views. So currently, countries require in-person voting, right? Most of them. Why do you think are the biggest challenges that they are facing for not adopting electronic voting? Like
Okay.
the approach you proposed. So if you had to go to the Peru government and say, I have here an electronic voting approach, what do you think would be the biggest challenges that the government is currently facing for not adopting these things?
Okay, in the case of Peru, would be the corruption. And
so that the data validity. Okay.
There is a lot of corruption. This is a main problem here in Peru too. Obviously, in my country, people with power with a high level don't want to be exposed by the but by real results that this application can show to to people, and will be more difficult for them to manipulate the vote.
And how could you still guarantee the anonymity of the voter with this approach? I think I didn't get that one.
In the same situation, because this project is focused in this case for universities.
Okay.
Do you want me to answer according if for my country or for universities?
No, for the approach that you
Okay.
are proposing. No, but
Okay, for my approach. As we are using just not sensible information, just the university code that is provided by university, and pictures. Every sensible information is provided by the institution. We don't store any sensible information.
Okay.
Yeah.
Yeah, okay, that answers my question. I just have one comment. So in terms of using an AI for facial recognition, there's a big resistance on that worldwide because, again, remember that AI can be highly biased. So there are many studies that show that facial recognition, automatic facial recognition, especially in African women, it has very low accuracy due to the low diversity of these types of representativeness in the data sets on these cultures. So just something for you to think on later is how inclusive your application is in terms of different cultures and individuals, because again, it's not a system that you trained, it's someone else's system, which means that you don't know how the training data was put together and how those biases could influence the recognition system. Okay, just a comment on that.
Okay, yeah, this is something interesting because Amazon recognition don't need a data set of pictures, only needs 2 pictures to compare. Fortunately, that's why we don't use a data set right now. We only, from the mobile phone of the student, they only take a picture of their faces, is sent to the service, and it's compared with the picture that is stored in the institution service.
Okay, so it's more a facial comparison rather than a recognition. Okay, cool. Okay, thank you very much, Martin. That's all.
Thank you
from us.
very much.
Thank you.
Thanks.
Ma'am, any other questions?
Yeah, even I just want to say thanks to Katrina also because whenever we just heard about this topic, e-voting, I think the first question, whatever she asked, I think everybody is having this kind of question in their mind. So I think the participant has already just covered the answer for that. So thank you, Katrina. I think in every country it's very tough to just adopt this e-voting system because most of the countries they are facing so many issues, but still they are not adopting this e-voting. So I think there are so many challenges for participants also to first we can apply any technology to solve that, but it's very tough to implement. So I think all the questions have been covered up. I think, but thanks for Katrina for asking all the questions. Whatever, I was having the same question in my mind. Thank you.
Thank you very much. Thanks a lot.
Thank you, ma'am. Thank you, sir. Now we are moving towards the closing remark of the conference. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th version and all the previous 8th version of the conference. We'll be happy to have you in the 10th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also thank our session chair, Dr. Minakshi, for chairing the session. This is the token of appreciation to the chair on behalf of team ICICT 2024 and Global Knowledge Research partners. Ma'am, kindly acknowledge our participants.
Yes, thank you so much for inviting me for this session. I think I am just chairing the session in this conference since last 3 to 4 years. So I think whatever series you are just going to adopt, I think the series is very good, and I think you are just going to implement, or you are just going to cover up all the points whatever required in the conference. And this is the main thing. I think you are just connecting all the international people for sharing this session. I think this is very good service. Whatever you are just going to just adopt all the services in your conference. So thank you so much for this invitation, and I think I would be very happy if I will be the part of in future also for this conference. Thank you.
Thank you, ma'am. Now I would love to extend my gratitude for Professor Katrina in recognition and appreciation of her knowledge, sharing as session chair at 9th International Congress on Information and Communication Technology.
Thank you
This is a
very
token
much.
of appreciation from the team of ICICT 2024 and Global Knowledge Research Foundation. Thank you, ma'am. Kindly acknowledge our participants.
Thank you very much. Again, I always enjoy coming here. It's not the first time that I participate in this conference. And what I like the most is the diversity of the works. And every year I'm always surprised by the creativity of the works on their research topics and the different research questions that currently are people are investigating. So it's always a honor to be here, and I'm happy to see next year the progress of everyone's work around here. So thank you so much.
Thank you, ma'am. Now I request everyone to turn on their cameras for a quick virtual snapshot. Thank you, everyone. Stay safe, stay connected. Thank you for your valuable presence. Take care.
Thank you, everyone.
Thank you. Thank you.
Thank you,
Bye.
sir. Thank you, ma'am. Thank you. Bye-bye.